We are in Chapter 6, Section 5, which is all about prime numbers. So this is the start of number theory. We're going to be moving away from using bases. And the big idea here is to understand what's a prime number and what's a composite number. First thing we're going to discuss is what is a natural number. So these are your counting numbers, 1, 2, 3, 4, and on. But 1 isn't considered prime or composite because 1 times itself is 1, so it doesn't really have any factors. So we're really talking about 2 and up. 2 and up. So I've already done an example 6.5.1. I've done A and C, so we're going to do number 42 together. We're going to determine all the natural divisors of 42. So when we think about 42, we'd have 1 and 42, 2 and 21, 3 and 14, 4 and nothing, because when we divided by 2 it wasn't even anymore, so 4 won't work. To be divisible by 5 you have to end in a 5 or 0, so 5's out. 6 and 7, and then because 6 and 7 are right next to each other, we know we got all of the divisors. Now alternately you could do like I did up here, and you could divide by every single number. Here I just want to point out that when I divided 6 by 2 I got 3, so that means that here our factors will be 1 and 6 and then 2 and 3. Because I got 3 evenly, I don't need to check 3 because I already have it in my list. So then here are the divisors of 42 are 1, 42, 2, 21, 3, 14, 6, and 7, or in order 1, 2, 3, 6, 7, 14, 21, and 42. The next big idea is what determining whether a natural number is prime or composite. So it's prime if it only has 1 in itself as factors, and then it's composite if it has any other factor. So when we look at 41, we know we have 1 and 41 as a factor, but what we want to do if we want to check all the numbers is we're going to take the square root of 41. When we do that on a calculator, we get 6.4. So what this tells us is we only have to check up to the number 6, and then we'll catch all the factors when we do that. So when we try 2, 2 won't work because it's not even. 3 won't work because 1 plus 4 is 5, and that's not divisible by 3. 4 won't work because it has to be even for 4 to work. 5 won't work because it doesn't end in a 5 or 0, and then 6 won't work because it was not divisible by 2 or 3. So this means that the only factors will be 1 and 41, which means that 41 is prime. Let's try another one. So now we're going to look at 51. So we have 1 and 51, and again I'm going to go through all the numbers. So let's do the square root of 51 and see what that's approximately, so we know what we need to go up to. Should be just a little bit bigger than 7. It's 7.14. So we have to check 2, 3, 4, 5, 6, and 7. So when we divide it by 2, well that's not going to work because it's not even, so that means any multiple 2 is also going to be out. When we divide it by 3, 5 plus 1 gives us 6, so 3 should work. So we get 3 and, we're just doing it on a calculator, 17. So automatically we don't have to go any further. This tells us that 51 is composite because it has at least one other factor. Now when we do 119, we want to do the same thing. The square root of 119 would be between 10 and 11, 10.9. So we know we have 1 and 119. It's not even, so 2's out. We try 3, but 1 plus 1 plus 9 is 11, so 3 is not going to work. 4 is not going to work because it's not even. 5 is not going to work. It does not end in a 5 or 0. 6 won't work because 2 and 3 are out. Let's try 7. When we divide 119 by 7, we get 17, which tells us that 119 is composite. So now that you've read about the divisibility test on page 339 in your textbook, or you've read through them in the professor's notebook on page 68. We're ready to work through an example using all the divisibility tests that we know. So just note that there's not one for 7, but we have one otherwise through 2 through 11 pretty easily. There is one for 7, it's just more complex. So when we use the number, when we do 2, it's even, so it should be divisible by 2. And we should get 81. And again, we know that because it's even. When we divide by 3, we add up the digits. So 1 plus 6 plus 2 gives us 9. 9 is divisible by 3. So we are divisible by 3, and we're divisible by 2 so far, which tells us that we're divisible by 6. We are not divisible by 4 because 62, we take the last 2 digits, is not divisible by 4. Because when we do that, we get a remainder, 15 remainder 2. When we try 5, that means we need to end in either a 5 or a 0, so that's not going to work. When we try 8, it's not going to work because 162 divided by 8 gives us a decimal, 20.25, or 20 remainder 2. So that's no, because there's a remainder or a decimal. Remember, for it to be a factor, there can't be any kind of thing left over. When we try 9, we add up the digits, 1 plus 6 plus 2, and we get 9. And 9 divided by 9 is 1, so it is divisible by 9. When we try 10, it's no, because it does not end in a 0. And then when we try 11, here's where we do the weird trick with the digits. So we're going to take 1, 6, and 2. So we're going to add up 1 and 2 to get 3, and then we take the other digit, 6, then we subtract, and then our question is 3 divisible by 11? The answer is no. So then 162 is divisible by 2, 3, 6, and 9. Now, the fundamental theorem of arithmetic tells us that every composite number can be written as a unique product of primes. So what this means is that every single composite number has a different pattern of primes that multiply together to create it. Remember, a prime number is a number that only has 1 in itself as a factor. So we already determined from the previous example 6.5.3 that 162 is divisible by 2, 3, 6, and 9. So what we're going to do is we're going to take 162 and we're going to do like a factor tree to find all the primes, and we're just going to keep going till we only have prime numbers. So because it's divisible by 9 and that one's the biggest, that one's going to be the first one that I pull out. So 162 divided by 9 is 18. Then we're going to break each of these down. 9 is 3 times 3. 3 and 3 are prime. So we're all done there. 18 is even, so we can pull out a 2 and we get 9 left over. 9 is again composite with 3 times 3, so we can do 3 and 3. So then that means that 162 is 2 times 3 times 3 times 3 times 3, or 2 times 3 to the 4th. And this would be our prime factorization. Usually you use exponents in a prime factorization. So you can look in your book on page 342 for an extensive list of all the primes up to 100. So what they do is they use what's called the sieve method, and they cross out every multiple, just like we talked about in example 651A and C.